This video involves mathematics, astrophysics, dynamics, and the three-body problem. An easy-to-understand explanation. How does Jupiter block the coma? The star is hurtling towards the Earth. Enter the positive film below. This is Comet Shoemaker, classified as number 9. July 16, 1994. Comet debris. The size of Colossus in the inner city of Rome. Mu Stadium. Start hitting Jupiter. The energy released subsequently is global. Hundreds of times the nuclear arsenal, leaving traces within months, marking Shoemaker's fate as number 9. This cruel incident was not unexpected. 16 months before impact, astronomers have identified a planet located on Jupiter, 4-degree angle celestial body, about the same distance as the Earth. It initially appears to be a single object. It's actually 21 major fragments. They move like a string of pearls. Time return velocity calculation display. 2 years before impact, a bigger coma. The star has crossed Jupiter's Roche limit. The difference in the attractive force of Jupiter to comets at that time, enough to tear it apart, and yet as powerful as Jupiter is. So much so that the difference is visually masked. By breaking it down into average forces and tides, forced to reveal this difference. This suggests that the coma, the back of the star, is not as strongly stressed as the front, drawn towards Jupiter. When these tidal forces overcome attractive forces, the comet will disintegrate, leaving a trail of gravel, reassemble into main pieces by attractive force. When uncertainties in all calculations are resolved, the next leap is determined to be only from the center of the planet, 45,000 kilometers. That's smaller than the radius of Jupiter. The collision became inevitable. The news went viral, with everyone anticipating this research opportunity. He became the first person in our solar system at that time. The most observed extraterrestrial object collisions. Although successive impacts cannot be seen by the naked eye, but within minutes of each impact, a stream of rain rises into the sun, visible from the Earth. A few hours later, dark spots swirl into view. Less than a week, all fragments hit, and use them as a potential threat to the solar system. Threat to erase Shoemaker. What makes being number 9 so fascinating? He not only exposed, shows part of Jupiter's internal chemistry. It also shows its huge presence, how to shape the orbits of comets throughout the solar system. This is Otmar, one with Shoemaker, listed as Comet 9, about the same size, still in space. Like Shoemaker, listed as the most likely origin of number 9, he was inside the orbit of Jupiter. But unlike Shoemaker, who is listed as number 9, and he survived. Scientists call this a temporary replenishment, swinging to Jupiter, which is currently far from the inner planet, Trek, although the two comets never threatened the Earth. Scientists began to study in detail Jupiter as the inner solar system, the role of the vacuum cleaner. But they were right. When a giant planet changes the coma like maze, star orbital time, what are the chances of him working in our favor? If Jupiter is helpful, is it to prevent an Earth impact? First, Jupiter may be both an enemy and a friend. The comet might swing into that orbit. That's exactly what happened in Otmar in 1937. His proximity to the sun activated him. Sublimate comet dust and ice into a hazy cloud. This enabled the comet to be discovered very quickly, but predicting the future is no easy task. Every close encounter between a comet and a planet makes predictions more uncertain. Several such contacts could cause a dramatic change in the comet's orbit. This is why we can't just rely on single prediction path. It should be seen as a series of possible scenarios. To really understand, how does Jupiter protect our solar system? We need to use statistics and systematic analytical methods. Imagine that the Sun and Jupiter revolve around their attractive force centers, forming solar system. This center is slightly above the surface of the Sun, a small comet. I've always been attracted by both. Draw a cut between the inner and outer tracks. Change path. Now, add more comets with the same energy. It's going to be very confusing. But now things are getting complicated. The camera starts to rotate to keep the Sun shining and Jupiter from left to right. This is what you will see. First, you will find an elliptical orbit with no camera rotation. Looks like a pattern from a rotating camera. That's exactly what we're looking for. It's near Jupiter, is the main orbital change, but at the same time, it's the only way in and out. It seems to be surrounded by an energy barrier. You'll never find our comet. In this forbidden area, it can't simply go through the hole. He must approach these passages, which are called popular. Now, these structures follow the coma. The energy level of a star varies. I'm going to show you where they came from. You can build heavy structures for multiple planets, stack twisted paths. But for now, this is the single planet model. Remember, did you mention we need structure and statistics? And now we have these structures. Let's add 1 million comet. So let's just assume they just, from the inner solar system, swing it out, leaving Jupiter's dominant sphere of influence. Follow the exit channel. Then you will find many comets will return at some point. But it could be a long time later. The opportunity to swing back only happens occasionally. The first return was after 23 years. This study reveals the outer solar system. How do you accept objects flying from within? When a coma, as the star approaches from within and follows the passage, he will have a delicate position, and the combination of speed values, forming a region embedded in four-dimensional space. 2 positions and 2 speeds. By cutting along a dimension, it can be drawn in the other 3 dimensions, channel slicing. This outer ring is cut by popular. It orbits the comet we just sent out. Now send 1 million to the inner solar system, comet leaving Jupiter. We can see 2 clusters. There is a dynamic rivalry. Due to the shorter orbital period inside, more opportunities to kick the comet back out. Ultimately, comets are more likely to be found on the outside. There is no Jupiter. 2 million track will not change. So under this setting, Jupiter inside, the cleaning up of the solar system has positive implications. But there's a catch. We don't actually need this barrier. This is a height map of attractive force potential energy. Its law gives an attractive force. This is what the comet sees as it wobbles. From the rotating camera, comets occasionally slow enough to stop and turn around. There's a point he won't pass. All these zeros, the set of relative velocity points, is the barrier. Because the barrier points themselves are spinning, the camera frame is fixed. They appear to be forced into a circle. Orbiting objects. Now to force an object. Enter a loop that does not consider camera rotation. Track. The centripetal force will correctly pull it into a circular orbit. From the rotating camera, objects must not move. So for balance, one must be added that is consistent with the camera changes. Fictional centrifugal force. As for the attractive force, centrifugal force is related to its own potential energy. The sum of the two gives an effective potential energy, forming an intersection with the total energy level of the comet. This line is the zero velocity curve or energy barrier. It changes with the energy of the comet. Since comets live in 3 dimensions, the energy barrier can be drawn like this. This means that any coma from above and below, stars must have higher energy. He's already in the forbidden zone of low-energy comets, so he cannot be affected by this protective model. But even high-energy comets that exceed the barrier, Jupiter can still deflect dangerous incoming comets. Here's the thing. In the absence of a comet energy barrier, is Jupiter a friend or an enemy? Reverse thinking. What makes celestial bodies a threat to the Earth as his orbit approaches Earth's orbit? It may collide with the Earth at some point in the future. We predict by observing the orbits of celestial bodies. Test this possibility. In a chaotic celestial system, many unpredictable factors can affect to the final trajectory of the celestial body. Therefore, many changes are likely to occur during the forecast period. But if your most accurate predictions, your predicted optimal trajectory, shows that a large object may be approaching, he is considered a potentially dangerous object. In 2 dimensions, close mostly means crossing orbits. They were called Earth walkers. To see how strong Jupiter is against these objects, strong attraction, they must approach Jupiter within this band and cut for each radius. There are a series of paths. Angle and velocity generate Earth piercers. Now, since Jupiter can only be in one place at a time, short-term studies show that only a few celestial bodies can approach Jupiter. Attractive force area. A better question is, since the object is within reach, Jupiter could effectively move them from Earth. Kicked out of the track? So, launch 10 million Earth crossers like this. Make them form a line. Jupiter just passed by. Most objects are still Earth walkers. This again reflects the limited extent of Jupiter. 350,000 object is no longer an Earth traveler. In these objects, 75,000 were completely ejected from the solar system. That's after the swing. They have positive orbital energy. They escape the system on a hyperbolic trajectory. This is Jupiter. Yes, it is already the Earth, the way the object of the penetrator is pulled. But that doesn't prove that Jupiter is friendly, because Jupiter could also be the first. Make objects become Earth piercers. These are made by 1 million Earth travelers. Send back. Look at Jupiter. How? Push them down that path to find out. Most of them are already Earth travelers. Focus on those that were not Earth before the wobble. Transmigrators. Jupiter first made them harmful. Can you see it? Use Jupiter to push objects back to where they came from. Push the object out with Jupiter. Is the same analysis. It's just a reversal of time. This is due to time reversibility. For Jupiter, kick an object in every path away from the Earth. There is an opposite mirror path. Objects are pulled towards the Earth. In terms of capacity, Jupiter is neither a friend nor an enemy. It depends on the object. How long will it take for the next encounter with Jupiter? The orbital period flat of the Earth transmigrator. Average non-Earth. Traversers have short orbital periods, more places to go, so even without an energy barrier. This also makes the object more likely accumulated in non-Earth transporter orbits. Many of them eventually left the solar system. Again, Jupiter clears that solar system. But this is optimistic, especially considering the solar system we are discussing. Incomplete reality is more complex. By this mechanism alone, We cannot rely on Jupiter because, all along, Jupiter also drives another problematic mechanism. This is the asteroid disk in the orbit of Jupiter, free from its dominant influence, uniform distribution of asteroids. Move along an elliptical orbit. It looks like a peaceful solar system, but only 20,000 years. That's about 1,700 times that Jupiter orbits the Sun. Some of the asteroids became Earth piercers. So even though Jupiter is far away, his influence can also reach us. The best way to drive this mechanism is to use objects in precise circular orbits. Now it only takes a few hundred years until a ring is formed. Everything is not evenly distributed. On the timeline of the solar system, it's just a blink of an eye. Soon after, the next ring appears, with all these gaps forming. We have seen the account according to the fate of these asteroids in space. It will take some time, but a lot of them end up here. These gaps are caused by orbital resonances. They dynamically destabilize the orbit. These resonances cause a swarm of objects. There are many potentially dangerous objects. So these are nearby objects, with their many orbits currently reaching us. They are the impact candidates that researchers are most concerned about, chosen but in our solar system. There are more short-term interactions to be aware of. The interaction is constantly sending us new objects. We have seen these objects from interstellar space and the outermost regions of the solar system reach us. We've seen Jupiter, in a very short interaction time, changed their trajectory, make them Earth travelers. But here it is. We built a portal. Gillian, even if it's no farther than Neptune, still able to get to Danatai, Yang system, for these low-energy trans-Neptunian objects. Most of them are blocked by energy barriers. It takes three mechanisms to reach us. Orbital portal, swing from the outer track to the inner track, plus a tricky orbital resonance sequence. Reduce the distance of its orbit from the Sun, and get ready for the next gateway. And here's an extra trick that I'll show you. How must a comet approach a planet to start the process? It comes with a programming tutorial. Teach you how to calculate these portals. If you are interested in this, see the actual code. These mechanisms can be more easily understood. See the detailed channel highlighting the true workings of portals. Portal popularity is rather complex. Make some excesses longer than others. It's not the fastest trajectory change. But eventually, the comet reached us. He doesn't even need to take all these portals. Here's a faster way. Let these low-energy trans-Neptunian comets, stars become Earth travelers, solar system with objects, the eternal melody of migration dances. Astronomers have made a lot of asteroids that could reach us, and comet maps. And there are many more dangerous objects that we don't yet know about. The best thing we can do, just keep researching and learn from the movements of our launch partners. This allows us to predict future impacts, but also appreciate our past. There are many hypotheses about the formation of the solar system, but we can be sure, in the earlier hotter stages 4.6 billion years ago, volatile molecules like water can only survive frost, extraglandular coagulation, and gravity accumulation, forming gas and ice giants and icy comets. Inside the frost glands, mainly non-volatile substances, as metals and silicates accumulate on rocky planets. All the things that didn't accumulate in time, all blown away by the solar wind. In later, colder stages, water can exist on Earth, but not at the time, to fill our oceans. There must be a mechanism. Ice-dropping material forms outside the frost line. Bring to Earth. This is why people believe that Jupiter and other giant planets, in sending life-enabling matter to us, played a supporting role. If this is true, so the question of whether Jupiter is a friend or an enemy, it's secondary. Jupiter gives as much as it takes. Because it cannot be ruled out that there is no early impact, there would not be enough life to form matter, maybe without us. Did you understand the content of this issue? Welcome to leave a comment for discussion.